Okay, you're right. Welcome to your tutorial on dividing with indices. So, last lesson we looked at multiplying with indices. Today we are going to look at the opposite operation, division with indices. Okay, so say we are given a to the power of 6 divided by a to the power of 4. We can also write that, and the way we should be writing that is a to the power of 6 over a to the power of 4. Now, if I break it down into what we call factor form, if I write out all of the factors, that's technically saying 1, 2, 3, 4, 5, 6 A's divided by 1, 2, 3, 4 A's. Okay, so this form down here, the way I've written it and what we've been doing a little bit last lesson, is actually called breaking it down into factor form. So a to the power of 6 divided by a to the power of 4, essentially when I break it down, looks like this. Now, as there are 6 factors of a on the numerator or on the top and 4 factors of a on the denominator, I can actually simplify it. Okay, I can actually simplify it. For every a I have on the top, I can cancel it with another a that I have on the bottom. So the first a I have on the top, second one on the bottom. I can only do 1 for 1. Think of it like an A for an A. Get it? Like an I for an I. Never mind. So I can only do it one at a time for every one that I have. So that's one taken off there, that's one taken off there, one taken off there, one taken off there, one taken off there. Now, because I've got 2 A's left on the top or the numerator, that's technically saying A times A over 1. Well, A times A. Now, because I've got nothing on the bottom, it's kind of over 1. And I'm not going to waste my life by writing over 1, because I just know that means A times A. A times A squared. Oh, okay. So, A to the power of 6 divided by a to the power of 4, 6, 4, equals a to the power of 2. Now, why am I saying this so slow like an idiot? Well, see a pattern much? I put patterns on this slide. I actually found this so funny for about 10 minutes. Now I'm recording it. Doesn't actually sound that funny. Anyway, yes, there is a pattern between a to the power of 6 and a to the power of 4 equaling a to the power of 2. It's not this pattern, but it is a pattern. So let me just take those patterns away. Oh, won't leave. Okay, cool. A to the power of 6 divided by a to the power of 4 equaling a to the power of 2. Now, I know with index law and I multiply, I can just add. With index law, when I am dividing, all I need to do is subtract whatever's on my numerator with whatever's on my denominator, okay? So technically what I'm doing here is I'm doing 6 subtract 4, which equals 2. So when you divide with indices that have the same base, instead of adding them, we're doing the opposite, so we subtract them. And that's the pattern. So let's have a look at a few examples. It says, simplify y to the power of 10, subtract y to the power of 3. Y to the 10 minus y to the 3. If I've got a 10 on the top and a 3 on the bottom, I check my bases are the same. Yep, more good. That means I can just simply 10 subtract 3. Okay, so that becomes y to the power of 7. Okay, if we ever get an example like this one, however, and it says d to the power of 12 divided by d to the power of 4, and it looks kind of like in that old school way that I used to be used to in primary school, always make sure we pop it d to the power of 12 over d to the power of 4. That way I can clearly see what's on my numerator and my denominator, and I know I can go 12, subtract 4, d to the power of 8. Now, if you're sitting there at the moment thinking, wow, I'm so smart, I totally get this, I'm just going to skip the rest of the tutorial. Next minute, you may get something like this. Whoa! Big numbers. Okay, this time, guys, we don't just have pronumerals, we also have numbers. So 36 d to the power of 7 on 12d to the power of 3. Now the rule when you have pronumerals and numbers, let's deal with my numbers first and my pronumerals second. So first thing we have to ask ourselves, is there a number that goes into 12 that also goes into 36? Let's do our factors of 12. 1, yep, that'll go into 36 as well. 2 goes into 12, yep. 2 goes into 36, yep, let's see if I can keep on going. 3, yep, that goes into both of them. 4, that goes into 12, no, yeah, okay, no. 5, no. 6, oh, yep, 6 will go into both of them. 6 6s are 36 and 6 2s are 12. Hold on, 12. 12 goes into 36 as well, doesn't it? So, if I deal with my numbers first, that's 3 times that 12 goes into 36 and 1. So that's them simplified. Okay, and at this point, I'm just going to write my d's next to it now. D to the power of 7, d to the power of 3. I notice if I've written 3 on 1, that's kind of actually a little bit of a waste of my time, because 3 on 1 is actually the same as just saying that. I don't actually need that, do I? So I can actually rewrite this as it's 3d to the power of 7, d to the power of 3. I know my indices law says that I can now take my 7 and subtract 3 from it. So that would be d to the power of 4. So my answer becomes 3d to the power of 4. 3d to the power of 4. How did I get that? Because I know with my index law I can take my numerator and then subtract my denominator if my bases are the same. In this case they're both d's, so they are. Whoa, Nelly. So this looks really hard, guys. It's actually kind of really easy. So the first thing I'm going to do, and the first thing I notice, is that I've got a multiplication on the top here. Okay, I've got multiplication. So it says 7t to the power of 3 times 4t to the power of 8. So let's deal with this separately. I've done multiplication with indices. I know if I have numbers and pronumerals, I deal with the numbers first. So 7 and 4 are one thing, and then my pronumerals I'll deal with second. Okay, so 7 multiplied by 4, 7 4s are 28. T to the power of 3 multiplied by t to the power of 8. When I have two pronumerals and they're the same bases and they've got indices on them, I know I can add them. So that becomes t to the power of 11. This here then becomes 12t to the power of 4. So I'm just carrying that through. So now that I've resolved my numerator, now I can actually do something. I'm going to ask myself, is there a number that goes into the top that goes into the bottom? So is there a number that goes into 28 that also goes into 12? The answer is yes. Okay, and long story short, I can do my factors out loud with you, but my answer is 4. 4 goes into 12 3 times, and it goes into 28 7 times. Now I have t to the power of 11, subtract t to the power of 4. So 11, 10, 9, 8, 7. I'm left with t to the power of 7. Okay, so my answer for 7t to the power of 3 times 4t to the power of 8 divided by 12t to the power of 4 becomes 7t7 divided by 3. And that's it, guys. That is dividing with indices.